Okay, before we move on to the next example, there's one thing I want to clarify about this P versus nu diagram. From last time, we know if you have a curve 1 to 2 on a P versus nu diagram, such as shown here, the area under the curve is equal to work W per unit mass. The next question is, what kind of work? There are two different kinds of work. What are they? So now we have to go to our two scenarios. The first case is if you have a closed system. The second case is when you have a control volume. For a closed system, such as a piston cylinder assembly, no inlet, no outlet, no mass transfer at all. You only have one work. It's just W, you can call it W total or WCV or just W. Doesn't matter because you only have one work, which comes from the moving piston. You only have one work. There's no other work you have to worry. So when you use W per unit mass equation, you don't have to worry about anything because there's only one work involved for a closed system. But if you deal with the control volume, things are different. Why? Because, for example, let's say you have a piston cylinder assembly again, but this time you have an inlet and an outlet. So this time your system will become a control volume, inlet, and outlet. For control volume, work is more complicated. First of all, you have total work. And then remember in our previous lectures, for control volume, W total has three parts. The first one we call WCV, which comes from the movement of the piston. So we can just say comes from the moving parts. And then in addition to WCV, you have two more terms. What are they? Minus P1V1 plus P2V2. What are they? P1V1, remember at the inlet, number one, what you do is you use the high pressure to push the fluid inside the control volume. If you push the control volume, that's consuming work. The control volume will consume work. If it consumes work, it has to be negative sign. Next, you use this pressure to push the fluid over a distance. What is that? Push something over a distance. That's work. And how do we calculate this work? P times V. So that's why the second term is minus P1V1. And same reason, we have a third term plus P2V2. That's for the exit, number two. At the exit, the control volume pushes the fluid out of it. If the control volume pushes, the control volume generates work. Generating work, it must be positive. And again, push something over a distance. How do we calculate that work? It's P times V. P is pressure, V is volume. The second term comes from the inlet. Third term comes from the outlet. So now you can see if you deal with the control volume, you have so many different kind of works, so many different W's. So when we go back to this P versus nu diagram, area on the curve equal to work per unit mass, what kind of work is it? It's always W total. Okay, so be careful. If you use this area under the curve, what you can find is always W total per unit mass. Usually for a control volume, we do not ask for W total. Usually we look for WCV. And how do you look for WCV for a control volume? Just keep that in mind. You look for if you have a moving part. If you have moving parts, then WCV will never be zero. If you do not have any moving parts, then WCV must be equal to 0.